Today we are going to start the subject thermodynamics. So what is thermodynamics? Thermo means basically heat, dynamic means power. And the basic purpose of this subject or main reason for origin of this subject is a commencement of this subject is just uh, because of increasing the efficiency and knowing the capacity of an heat engine. What heat engine can do, what maximum heat engine can do, and heat engine is a device which can convert the heat into power. So basic purpose of introducing this subject or commencement of this subject is how efficiently we can convert the heat into power, because in the 19th century that industrial revolution was in the peak, and the basic purpose in industries was how we can convert the heat into power, because through power we can produce electricity and all, huh? So that was efficiency in the late of 19th century. The efficiency of the heat engine that were used in that time were very less. So then some of the engineering community has decided to arrange a meeting, and in that meeting to discuss many things, and the main core of that meeting, main purpose of that meeting was how we can enhance the efficiency of an heat engine. So that was the reason for commencement of this subject, thermodynamics. The main purpose is conversion of heat into power. Efficient conversion means how can increase the efficiency of an heat engine so that we can easily convert our maximum possible conversion of heat into power is possible. Okay, so that we can know what maximum heat engine can do. Clear? So that was the history about thermodynamics. Clear? So at the last of the subject you will be able to know the main purpose is the same, how efficiently we can convert heat into power. As I told you, in 18th of 19th of century, in late 18th, or you can say, or better is that in 19th century, where industrial revolution was very fast, so they were use a heat engine which can convert the heat into power, but the efficiency of that heat engine was very less. I told you in that time the some of the engineering community has been decided to arrange a meeting, and in that meeting they decided uh, to introduce a concept of thermodynamics, and through that concept they able to discuss how we can increase the efficiency and what is the maximum possible efficiency of an heat engine. Okay, apart from this, that was main core central purpose, but what they also found along with this as a byproduct, thermodynamics is a subject that always set a limit of maximum and minimum, what maximum you can do and what minimum you can do. This subject also set the limits for an engineer to do what the maximum is possible. Suppose if anyone is trying to devise an engine which can uh, which suppose as an engineer I am just want to design an heat engine, I want to develop an heat engine, or which or any engine, any device we want to develop which can transport the energy from low temperature to high temperature simultaneously or spontaneously without using any work. Is it possible? is it possible to devise any heat engine or any device? Is it possible to develop any device which can transfer the heat from the low temperature to high temperature without using any work? That's not possible. No matter how much time you are devoting, you are wasting your time. So the best thing about thermodynamics is that thermodynamic will tell you what you can't do, because there are many things in the universe which you can do, which is possible, but very certain things are there which is not possible, that you must know, otherwise you will waste your time in doing this. So in short, you can say thermodynamic subject will tell you about the feasibility of the process. Is this process is feasible or not? And if it is feasible, then what the maximum extent of that process, what a maximum limit of that process, that will also be decided by the thermodynamics. Clear? So, and best part of this subject is not restricted only for the engineering purposes. It can be used in any science and engineering, in any branch, in any stream, in science field also, in engineering field also, because everywhere it is simply thermodynamics describes simple law of nature. What is law of nature? The law of nature is that heat spontaneously can transfer from the high temperature to low temperature without any work. Spontaneous. But reverse is not true. Water always falls from the higher elevation to lower elevation spontaneously without doing any work. Two gases can be mixed spontaneously. For mixing, you should not require any work. But reverse is not true. You can't unmix the two gases without doing any work. Yes or no? You can't transfer the liquid from the lower elevation to higher elevation without using any pump. Yes or no? You will get, you will grow and become old. You can't become young. Yes or no? Your hair become white. It will not become black with your age. Yes or no? So it's simple law of nature. Reverse is not true. You will become old spontaneously. If you can't do anything, still you will become old. But you can't become young without doing any effort and all. Current always flow from the high voltage to low voltage. Reverse is not possible. So what I'm saying to you, ki there are some certain processes are there in the universe. I told you thermodynamics simply describe the law of nature, and law of nature means there are there are some certain processes are there in the universe which are possible in only one direction. Means processes which are taking place in the universe, they are not at random. They are taking place in some certain direction. They are not at random. At random means it is not possible. Means heat always travels from the high temperature to low temperature. There is some certain direction is there. Reverse is not possible spontaneously. If you want to do reverse heat transfer, then you should do some work. That what you did supply in a refrigerator. What refrigerator does? You freeze, transfer the energy from the low temperature to high temperature. But for doing this, you have to pay in terms of electricity. Yes or no? Freeze doesn't work free. Same thing, the AC also transfer that energy from the low temperature to high temperature, but for this you have to pay for it in terms of electricity bill, power. Yes or no? The meaning is that there are some certain, whatever the process is taking place in the universe, they are not at random. Some of the processes are only possible in one direction. For example, transfer of the heat from high to low temperature, transfer of current from high voltage to low voltage, transfer of mass from the higher concentration to lower concentration, transfer of current from the high voltage to low voltage. They are only possible in one direction. Reverse is not possible spontaneously. If you want to reverse, then you have to do some work from surrounding. Yes or no? At the same time, there are few processes are there in the universe which are possible in the both direction, but there are few processes also there which are possible in both direction, but again there is some constraints are there. Constraint means the restriction behind that is there. All those I told you some examples of the processes which are taking place in only one direction, but there are few processes are also there which are possible in the both direction, but there is also some constraints are there behind it, some restrictions are there behind it. What restriction is there? For example, a gas can be compressed and expand. Suppose a gas is there, you can compress it, you can expand it. So when you compress the gas, from this volume to this volume, this is the piston here. Initially volume is V1, now you compress to volume V2 by applying the pressure. When you expand the gas, when you release the pressure, system will again regain its initial state from V2 to V1. Yes or no? So compression is there and then expansion is there. So in compression and expansion, system reach to its initial state, but surroundings suffer a permanent change. Do you know? Surroundings suffer a permanent change. Can you tell me how the surrounding will suffer change? If piston cylinder assembly is system, so if you compress the gas, if you compress the gas, then my question is that is when you compress the gas, some work has to be done. Some work has to be done on compression. And when you expand the gas to reach its initial state, then work is done by the system. In the first 1 to 2, when I compress the gas, during compression work has to be done by the system, by the surrounding on the system. Work has to be done on the system by surrounding. And when you expand the gas, work is done by the system on surrounding. So is both are equal and opposite in magnitude? Is the both are equal? Work done during, because we are reaching to initial state from 1 to 2, 1 to 2, again from 2 to 1, from V1 to V2, again V2 to V1. So work done during compression is not equal to work done during expansion. Why? Because frictional effect is there. Due to frictional effect, some of the work done during compression will dissipate in form of heat due to frictional effect, because friction is there in between the piston and cylinder. Yes or no? So due to friction, some of the energy will get dissipated in form of heat. So here compression and some of the processes are taking place in the both direction, means compression and expansion, but in this case restriction is there. During this process, system, although system reach to its initial state, but surroundings suffer a change, because whatever the heat is there, that heat transfer to surrounding, and surroundings suffer a permanent change. Means when you reverse the process, surrounding, whatever work you have extracted from the surrounding, you are not transferring the exact amount, same amount of work to the surrounding? Yes or no? तो surrounding suffer change ना, बोलो भाई. Whatever work you have extracted from the surrounding during compression of the gas, if you are able to transfer the same amount of work during expansion, then I can say कि surroundings will not suffer change. But in this case, are you able to transfer the same amount of work? No, because some of the energy get also transferred in terms of friction. So surroundings suffer a change here. Clear? One more example. Suppose if here a surface is there, over surface a block is there of mass m. If you are going to pull the block from one point position to the second position, then obviously you have done some work. Without doing work, it's not possible, na? You did some work in order to place the block from position m1 to position 2. But in doing so, due to frictional effect, what happened? Due to friction effect, its temperature will get increases. Because for example, if you are going to rub your hand, है ना, when you rub your hand, then temperature get increases, your temperature of the hand get increases. If you rub your palm, then obviously you might find temperature get increases. Yes or no? Okay, so what happened here, listen, from if you again place this block to its initial position, initially what you did, you just transfer the block from one point to 2 point by pulling it, and then again what you did, you just again transfer to its initial position 1, from 2 to 1, the same block. In doing so, although block physically reached to its initial position, yes or no? But what about temperature? What about temperature of the block? Will get increases or not? Tell me. Whatever temperature of the block was initially, let's say, of 25 degrees Celsius, now this block, because due to frictional effect here, and again you reverse, when you again pull it back in the reverse direction, temperature, that due to friction temperature get increases, it becomes, let's say, 26 degrees Celsius. And to reach the system to its initial state, to reach the system of block to its initial state, then you have to transfer heat to surrounding to make it 25 degrees Celsius. Yes or no? Because if you want to reach the system to its initial state, it should not be only physically, it should be in all respect. So if let's say temperature has been increased by 1 degree Celsius, then that if you want to come back, if you want to take the system to its initial condition of the temperature 25 degrees Celsius, you have to transfer the amount of heat that reduce the temperature by 1 degree Celsius to surrounding. So system reached to initial state, but what about surrounding? Surroundings suffer a change in terms of heat transfer, yes or no? Similarly, if suppose there is a two bodies are there, one is body at high temperature, other body is at low temperature, then simply heat can transfer from high temperature to low temperature. Clear? Let's say Q amount of heat has been transferred. But if you want to reverse the process, is it possible to spontaneously? Here from height body, let's say the two bodies are there at two different temperature, one is at high temperature, the low temperature. The heat can be transferred simultaneously without doing any work. But if you want to reverse the process, what you should do? You have to supply some work on it. So by doing work, you can reverse this direction equal amount of heat has been transferred, but you have taken the work from surrounding, na? You have extracted the work from surrounding. So whatever the Q you have transferred, a same Q will reverse here, but surroundings suffer a permanent change in terms of work transfer. Yes or no? So what is the meaning of saying all this? Ki whatever the processes are taking place in the universe, they are not at random. Some of the processes are only possible in one direction. Some processes are possible in the both direction, but there are some certain rhythm are there. They are taking place in with some certain restrictions are there behind it. Every process is not at random. Whatever we are means whatever the process are taking place in the universe, every process are taking place in some certain rhythm. There is some directional constraints are there. Some of the processes are only possible in one direction. Some processes are possible in the both direction, but there are again some constraints are there. Constraint in terms of system may reach their initial state but surroundings suffer permanent change. So that restrictions behind the processes is called as directional constraints. Is called as directional constraints. Is this clear? Means directional constraints behind the process means the processes are not at random. They are not taking place in any direction. There are some certain rhythms are there. There are some certain direction is there in which the process is possible. So that directional constraints is given by the thermodynamics in terms of second law of thermodynamics. In terms of entropy, I will discuss. Clear? So what is the purpose of this subject? Is this clear? First, the subject has been started to because of just they are in that time they were suffering from the low efficiency of the heat engine, and that's why they just introduce a concept of thermodynamics. But along with this concept, we are also able to know some more things that we are through that concept we are also describes the law of nature. And law of nature is simply we have defined in terms of first law and second law of thermodynamics and zeroth law. So zeroth law, first law, second law is nothing, it's simply law of nature. Clear? So whenever you talk about thermodynamics, you should only know it's all the law of thermodynamics is simply the law of nature. And the law of nature has been written in terms of mathematical form by the thermodynamics. So what is the role of thermodynamics? Is simply describes the physical laws that governs the all the physical processes which are taking place in the universe, and they also provide directional constraints for the processes. Every process in the universe is not at random, they are taking place in some certain direction. There are some certain restrictions behind it, and that restrictions is going to be given by the thermodynamics in terms of second law and entropy. Clear? So as far as the role of chemical, as far as what is the importance of thermodynamics for the chemical engineer, as a chemical engineer, you know chemical reactor is a core of any industries, and in chemical reactor chemical reaction is going to take place. So if you want to check is the chemical reaction is feasible or not, how you can check the feasibility of any processes, not only chemical reaction, any feasible. If you have a device and an engine, if you want to check it feasible or not, if you want to carry out a chemical reaction, is the chemical reaction is feasible or not at the given set of operating conditions, that you can check by the thermodynamics. So thermodynamics, through thermodynamics you are able to know is this chemical reaction is feasible or not at the given set of operating conditions. Because you know very well, you already done the CRE. Every chemical reaction, if you suppose even oxygen and nitrogen that present in the atmosphere, they can react at very high temperature, yes or no, and they will form the nitrous oxide. But is it possible to, because already you know कि oxygen and nitrogen is present in the atmosphere, they can react at all temperature and pressure? No, they can only react at the some certain set of temperature and pressure. So every chemical reaction which are taking place, they are not possible to take place at all temperature and pressure. They are only feasible at some certain set of temperature and pressure. Means there again restriction is there behind the reaction. Yes or no? We see. So every process, any chemical reaction is not possible at all set of temperature and pressure. So first of all, if you want to check the feasibility of the reaction, is the reaction is feasible at this set of temperature and pressure or not, that you can check by thermodynamics. If it is feasible, then what the maximum possible conversion of this reaction is there at the given set of temperature and pressure. Again, listen, first purpose of a thermodynamics as a chemical engineer is that they can check is the reaction is they can check the feasibility of a reaction at the given operating condition of temperature and pressure. If it is feasible, then second problem is what is the maximum possible conversion of that reaction. What is the extent of that chemical reaction? Yes or no? Is it 80%, 90? You know very well every reversible reaction has a limited conversion of equilibrium conversion. The conversion cannot be 100% if the reaction is reversible. So every reversible reaction has the limit set by thermodynamics, and thermodynamics will decide what is the maximum possible conversion. The maximum possible conversion attained by any chemical reaction is described by the thermodynamics. Clear? So thermodynamics will decide what the maximum possible conversion is there. And the rate of chemical reaction does not define the what conversion can attain. Rate of chemical reaction is only how fast the reaction can achieve that maximum possible conversion. Is this clear? Thermodynamics will describe if any reaction is there, A gives B, this is a reversible reaction, then what the maximum possible conversion that can be attained at the given temperature and pressure, that is by thermodynamics. Is it feasible or not? That is by thermodynamics. If it is feasible, then how much maximum possible conversion is there at given temperature and pressure, that is by thermodynamics. So what is the role of kinetics? Kinetics will not define the maximum possible conversion that attained by the reaction. Kinetics of the reaction, you might have studied. The kinetics is only describe how fast the reaction will achieve that maximum possible conversion. That's said by the thermodynamics. That has been said by thermodynamics. Clear? If the rate of reaction is fast, then in a small time that will attain the limit. Now third rule of thermodynamics is that how that maximum possible conversion that is at the temperature and pressure, how it is going to vary with the operating conditions. I told you at this given temperature and pressure, the maximum possible conversion, that is called as equilibrium conversion, XAE, that can be also vary with the temperature and pressure. That you might have studied in non-ensemble reaction. XAE, equilibrium conversion with temperature. If reaction is reversible exothermic, then equilibrium conversion will get decreases with temperature. And if reaction endothermic, it will increase with the temperature. Yes or no? So temperature is going to be affect the temperature is going to affect the equilibrium conversion. So that is going to be decided by thermodynamics. So thermodynamics, and you might have used want of equation for that. Right? So what I'm saying to you, the first you can check the feasibility of chemical reaction. Once you reaction is feasible, then you can also check what the maximum extent of the reaction is there at the given temperature and pressure. Third, how the maximum extent is going to vary with the operating conditions. Is this clear? These all are going to be checked by the thermodynamics. Clear? So thermodynamics sets the limit what you can do and what you can't do. So it sets the maximum and minimum limit. For example, at this temperature and pressure, that reaction have maximum conversion of 90%, that is set by thermodynamics. thermodynamics will set कि that is the maximum possible conversion of 90% at this given temperature and pressure. Now as an engineer you have to design a reactor, you have to design a reactor to attain that maximum possible conversion, because if any other person is trying to design a reactor which can produce, which can uh, have a conversion more than 90% at this temperature and this pressure, they are wasting their time. Clear? Because its maximum limit is there, you can't go beyond that. So as an engineer you have an opportunity, because once you know the maximum limit, then accordingly you will design your reactor to at least attain that much conversion, or at least you should tend towards that conversion. Yes or no? Bolo. Because once you know what the maximum possible maximum limit is there, accordingly you should change your design. If you don't know what the maximum possible limit is there, then obviously you will be in dilemma. So thermodynamics, what advantage of thermodynamics is, thermodynamics says the limit. What is the maximum, and accordingly as an engineer you have an opportunity to design a reactor to attain that maximum possible conversion, to that attain the maximum limit. Is this clear? That's what thermodynamics I told you. The very importance of thermodynamics is there in our life. So as far as introduction is concerned, I can say thermodynamics, it is a branch of science and engineering that deals with energy and energy transformation. That deals with the energy and energy transformation. Clear? So it is a branch of science and engineering that deals with the energy and energy transformation. Or we can say better is that it is a branch of engineering that deals with the process. एक 1 minute. You can also write that deals with the energy and energy transformation, or also you can say it is a branch of science and engineering that it is a science of engineering it is a branch of science and engineering that describes law of all the physical laws, that governs that governs physical processes associated with energy and energy transformation. Clear? So it is a branch of science engineering that describes the physical laws for physical law which governs the physical processes which are taking place in the universe, which are associated with the energy and energy transformation. The any physical processes which involves the energy and energy transformation, for that physical processes that describes the laws for it. Clear? The energy transformation means to is this clear? So that subject will simply describe the law, physical laws which governs the physical processes which are taking place in the universe, which are associated with the energy and energy transformation. Any physical process which are associated with the energy or energy transformation, for that physical processes it describes the law. That is the objective of thermodynamics. Clear है? Clear? So any physical processes which are taking place in the universe, you can consider any example. Suppose if any block is falling from the one elevation to if you drop the ball, then if you drop the ball from elevation to the ground, then obviously that is associated with energy and energy transformation, because here potential energy is going to convert into kinetic energy. Yes or no? This is also, this is the process when you fall the ball from the higher elevation to lower elevation. It's also associated with the energy and energy transformation, because in this case the potential energy of the ball is going to convert into kinetic energy before striking the ground. Yes or no? And apart from this, it also provide the restrictions. I told you, no, it is very simple definition, because also I told you every process which are taking place in the universe is not at random. They are taking place in some certain direction. So the rational constraints behind the processes is also given by the thermodynamics. Clear? Means you process feasible or not, that all you can answer of the question is by thermodynamics. Now come to the approaches. There are two approaches there to study the thermodynamics. One is called as classical approach or microscopic approach. Microscopic approach. And microscopic approach. Macro and micro. Two approaches there to study the thermodynamics. In microscopic approach, as you know, every matter is comprising of large number of molecules or atoms. Every matter comprising of large number of molecules or atom. Huh? So in microscopic approach, this is also called as large scale. Means at the gross level. Here it at the molecular level. In microscopic approach, we are going to bother only at the gross level without bothering about any event occurring at the molecular level. So in this approach, a certain quantity of matter. Matter means, a certain quantity of matter considered without, a certain quantity of matter is going to be considered without taking, without bothering about any events that are occurring at the molecular level. Means we are not going to bother about how the molecules are going to behave, because every matter comprising of large number of molecules, and every molecules are moving with random velocity, with random magnitude, in random direction. Yes or no? And they are going to collide with other molecules. On upon collision, they will change their velocity in both magnitude and direction. So molecular motions are very quite random. So the two approaches there to study the thermodynamics: one at the molecular level, other at the microscopic level. So in this approach, a certain quantity of matter is going to be studied. A certain quantity of matter is considered without taking any event occurring at the molecular level. In other words, approach to thermodynamics is concerned with the gross or overall behavior of the molecules. We are not going to talk about individual molecules. We are not going to bother about the what events is, how the molecules are going to move, how the molecules are going to, what is the velocity of molecules, what is the kinetic energy of molecules. We are not going to bother any event at the molecular level. We are going to observe its gross effect. Okay, that is called as microscopic approach. And in this approach, the changes in the properties can be sensed by the human operator. So first of all, you should know what is the in this, a certain quantity of matter is considered without taking any event occurring at the molecular level. Or you can say, in this approach of thermodynamics, it is concerned with the gross or overall behavior of all the molecules. So obviously in this approach, the study of nature of the molecules is not important. Means study of nature of the molecules or study of behavior of molecules is not important, because we are talking about gross behavior, average behavior of molecules. So what are properties we are going to measure in this approach? That are the average properties of all molecules. For example, if I'm talking about, let's say, in a container, some gaseous molecules are there, gases are there, na? So every molecules will strike on the wall and they will exert the pressure. So what is the pressure at the microscopic level? The pressure is nothing, it's a rate of change of momentum per unit area, because rate of change of momentum is force, and force per unit area is called as pressure. Yes or no? So actually, if you define the pressure at the molecular level, then this is nothing, it's the average of rate of change of momentum per unit area of molecules. I told you that molecules are random in the motion, and that molecules are going to strike on the wall, and that causes the change of momentum. So rate of change of momentum per unit area of the molecules, rate of change of momentum molecules on the unit area of this object is called as pressure. So if you want to define the pressure at the molecular level, you must know the rate of change of momentum, how the molecules are going to strike, what their rate of change of momentum, and for this you should know the velocity of molecules, you should know the momentum of the molecules and all. Then you can find the pressure. But in the microscopic approach, we are not going to bother any event which is occurring at the molecular level. We just use the Bourdon tube pressure gauge and that device, simply measures the pressure, and that pressure is what is called as average behavior. So we are not going to, if you want to measure the pressure of a system in a gas, in a container, then you never bother about what is the rate of change of momentum of molecules, what is the velocity of molecules, what is the momentum of molecules. Have you ever bothered about this? No, you simply use the pressure gauge and you can measure the pressure. So that is what is called as a microscopic approach. In this approach, whatever properties, either pressure, similarly, if you want to measure temperature, so temperature is what? Temperature is a measure of kinetic energy of molecules, and every molecules are going to move with the different kinetic energies. Yes or no? So if you want to measure temperature in the microscopic level, this is simply the average of rate of change of kinetic energy of the molecules. So that we can directly measure by using the thermometer. If you place thermometer, that will simply indicate what the temperature is there. So that temperature is at the gross level. Its overall behavior, and that is simply, it means just like pressure and temperature. That is, the pressure is the average of rate of change of momentum, or average of the pressure of exerted by the individual molecules. So we are not going to bother any event which is occurring at the molecular level. We are taking the gross behavior. Clear? Temperature, pressure, volume. If you want to find the volume, then simply we should know the dimension, length, width and height. I can find the volume. We are not going to bother about how much volume is going to be occupied by the, what is the size of molecules and all, how much is vacant, how much is not vacant. Yes or no? So what is this approach? It's called as microscopic approach. Is this clear? In microscopic approach, a certain quantity of matter is going to be considered without bothering about any event occurring at the molecular level. So in this approach, thermodynamics is concerned with this approach, or you can say this approach to thermodynamics is concerned with the gross overall behavior. And obviously, since it is average, what I'm saying to you, since macroscopic approach is the average of microscopic behaviors of molecules, yes or no? That's why it will be correct. We are not going to be, if you are taking the average, then microscopic approach, whatever result we are getting through microscopic approach, that is obviously correct, because it's result from the average of microscopic approaches or microscopic behavior. I told you, for example, temperature at the microscopic level is nothing, it's the average of kinetic energy of molecules. Clear? Pressure is the average of rate of change of momentum per unit area is called as pressure. So since it's a gross behavior or average behavior, that's why it will be correct approach. Is this clear? So again, microscopic behavior or any change in property in this approach can be sensed by the human operator. For example, temperature, pressure, you can directly measure by using the devices. Clear hai? While in the microscopic approach, this approach considers that the system is made up of, every a certain quantity of matter. A matter is comprising of large number of molecules, discrete particles known as molecules, and these molecules have different velocities and energies, and the value of these energies are constantly changing with the time and position. This approach to thermodynamics, which is concerned directly with the structure of matter, is known as statistical thermodynamics, and this is called classical thermodynamics. Any approach in this is called classical thermodynamics, and this is called as statistical, because we are going to bother about any event occurring at the molecular level, and that's called as statistical thermodynamics. Just like in the mechanics, two mechanisms there. One is called as classical mechanics, and another is called as statistical mechanics. So in thermodynamics, the two approaches there. One is called as microscopic, another is microscopic approach. In microscopic approach, we are not going to bother about any event occurring at the molecular level. We are going to take the gross behavior of the molecules, which can be sensed by the human operator. Now, in this approach, we are going to bother all the events which are occurring at the molecular level. Right? So in this case, the knowledge of behavior of molecules are very important. While in the microscopic approach, the knowledge of behavior of molecules is not important. Is this clear? And that's why in microscopic approach the analysis requires a simple mathematical formula, while in the microscopic approach this analysis requires the very large or very complex mathematical formulas. And I told you in the microscopic approach all the values of properties like pressure, temperatures are their average values of the molecules. For example, I told you consider a sample of a gas is closed in a container. The pressure of the gas is the average value of pressure exerted by the millions of the individual molecules. Or you can say pressure is the average of rate of change of momentum of the million of the molecules striking on the wall of the container. So we are not going to bother about the million molecules and their rate of change of momentum. We are simply bothering about their average effect, gross effect, and gross effect of the molecules we are going to measure with the devices like pressure gauges. Clear? Similarly, temperature of the gas is the average value of translation kinetic energy of the million of the individual molecules. You can say temperature of the gas is the average of rate of change of kinetic energy of the million of the individual molecules. And these we are not going to measure the kinetic energy of individual molecules. Instead we are taking the gross effect of that, and gross effect we can measure in terms of thermometer. And the properties like pressure and temperature we can easily measure. We can't measure the average of kinetic energies. If you want to measure the pressure and temperature at the microscopic level or in the microscopic approach, we should bother about the velocities and kinetic energies of individual molecules. Then we can find the pressure and temperature. But if you're taking the average effect, that is what is the pressure that we can directly measure by the devices. And in microscopic approach a very few variables are required to define a system, while in the microscopic approach large properties has to be fixed to define the system. Clear? Large number of variables are needed to describe a system. That's why this approach is very complex. Is this clear? And both approach will give the same result, because microscopic approach is the gross behavior of microscopic approach. That's why whatever result we are getting through microscopic, same result we are getting through microscopic approach. That's why we are, and since microscopic approach is simple in study, that's why we are going to start the microscopic approach, and that is called classical thermodynamics. Is this clear, beta? Bolo. So what is difference in these two? Is this clear? Micro and microscopic approach. You can write in one point at least. Certain quantity of matter in this approach, certain quantity of matter is considered without bothering any event occurring at molecular level. it is concerned with gross or overall behavior. ठीक है. This approach require simple mathematical relation, a formula, simple mathematical formula ठीक है. In this approach change in the properties can be felt by our senses, felt by human operator. Can be sensed by human operator by using the devices like pressure gauge and thermocouple and all. And it requires to define the system through this approach, less number of variables has to be fixed. Very few number of variables are needed to define the system. Is this clear? Now in the micro you can write the reverse of that. In this case if in microscopic you can write every matter comprising of large number of molecules, and these molecules have different velocities and energies. So in this case what you can write in simple, in this approach a certain quantity of matter which comprising of large number of molecules, and all molecules are moving with a different velocity, with different temperature, with different kinetic energies. And in this approach we have to bother about all the events which are occurring at the molecule level. Means a certain quantity of matter is going to be analyzed with considering the event occurring at the molecule level. Clear? And this approach requires the very complex mathematical formula. In this approach the change in properties cannot be felt by human sense. Very large number of variables are needed to define the system. Clear? Can you write? So this is the classical thermodynamics, and this is called statistical thermodynamics. Statistical thermodynamics. Clear? So we are going to start which approach? Microscopic approach, which is easy to analyze. Now next thing is that only बस समझ लो, no need to write. Some definitions, types of system. What is system? What is surrounding? तो definition system and surrounding. System, surrounding, boundary, and universe. Ready? So what is system? System is defined as quantity of matter or a region in a space. What is system? System is a certain quantity of matter, a certain quantity of matter or a region in a space, region in a space upon which attention is concentrated or focused, concentrated in analyzing the problem, in analysis of problem is called a system. So system is what? A certain quantity of matter. Certain quantity of matter means, for example, let's say this is what certain quantity of matter is there, or a region in space. Let's say space is there, we are going to bother about only small region upon which our attention is concentrated only on that region. That's called a system. Is this clear? A certain quantity of matter or a small region in space on which our attention is focused or concentrated, that is called as system. Anything beyond the system is called as surrounding. Anything beyond the system is called as surrounding. Clear? Except for system, all rest is called as surrounding or environment. And the system is separate from the surrounding by the system boundary. So what is boundary? A line which demarcate system from surrounding is called as boundary. The system is separated from surrounding by line called as boundary. And this line or called as boundary which demarcate the system from surrounding, which separate the system from surrounding, is maybe either fixed or moving. The boundary may be fixed or moving. ठीक है. Now a system and its surrounding together comprise a universe. A system plus surrounding as a whole is called universe. System along with system and surrounding as a whole is called as universe. Clear? Any problem in this definition? System, surrounding, boundary, and boundary may be fixed or moving, that I will discuss here. Types of thermodynamic system. Types of thermodynamic system. There are three types of thermodynamic system is there. One is called open system. First I write in closed system. Open system. Isolated system. Closed, open and isolated. Closed system is also called as control mass system. Control mass system. It's called control volume system. ठीक है. What is closed system? A closed system is system of control mass, means here mass is fixed. Closed system is system of fixed mass and identity. As far as closed system is concerned, closed system is a system of fixed mass and identity. Means mass and identity are fixed. Means there is no interaction of the mass between system and surrounding. It means no interaction of mass between system and surrounding. Means mass cannot cross the boundary. ठीक है. No mass can in, no mass can out from the system. हाँ, energy interaction is possible. Means there is no mass transfer across the system boundary. That's why the mass and identity will fix here. The no interaction of mass between the system and surrounding, or you can say there is no mass transfer across the system boundary. There may be energy transfer into and out. There may be energy interaction between system and surrounding. No mass interaction, but energy interaction is there. Clear? Example of closed system is that. So can you say in a closed system it is a region of fixed mass? In this region a certain quantity of matter is fixed. Quantity of matter is fixed. For example, if a piston cylinder assembly is there, It's a piston, its cylinder is there, its piston is there. Here some fluid is filled here, let's say water. Clear? In this case, this is what is called as system. This is the dot line I am going to show you. This dot line is actually boundary. Clear? And within the boundary, this is what system. This is what system is there. So you can see this boundary is, let's say, A, B, C and D. Boundary AB, boundary AD and boundary DC, they are fixed, but boundary BC can be moved by moving the piston. This is movable boundary. That's a boundary by fixed and movable, and these are fixed boundaries. Fixed boundary. Yes or no? Bro, fixed boundary, fixed boundary. The boundary may be fixed and movable, I told you. And anything beyond the boundary, beyond the system is called surrounding, and the line which demarcate the system from surrounding is called boundary, I told you. So in a closed system, here you can see, because it is closed, no mass can be in and out. Anything beyond the system is called a surrounding. Its surrounding is there, or environment. So no mass interaction is there. So can you say in simple, if it is system is said to be system, and this is what is called as surrounding, and this is our boundary, there is no mass interaction. Between system and surrounding, but there is energy interaction is there. Means you can heat this, you can transfer energy, you can remove, you can extract energy from, you can transfer energy from surrounding system, or you can also transfer energy from system to surrounding. Energy interaction is possible, but mass interaction is not possible. It is clear, mass is fixed. That's why it is called as a region of fixed mass. Here certain quantity of fixed matter is there, certain quantity of matter is there. Clear hai? The certain quantity of fluid in a cylinder bounded by a piston constitute a closed system. This is a closed system. Any example of any other example of closed system? Air fill in the balloon. The air fill in the balloon, it's also closed system, because if balloon is here tightly packed, or you can say here, then no air can be in and out. If you allow the air to flow out and in, then it's open system. So as long as the balloon is of fixed size, then no mass can in and out. Balloon of fixed size. A rigid vessel. Do you know rigid vessel? Let's say you have a rigid vessel. Rigid vessel means which size cannot be changed. So let's say if you have a hemispherical ball, if you have a spherical ball, the spherical ball is a closed system, yes or no? Because any air in this ball is a closed system, because no mass can in, no mass can out. Although we can heat this gas and cool this gas by transferring the energy. So this is a closed system. You know very well. Clear? What is open system? Also called as control volume system. In this, the mass can transfer across the boundary. In open system, there is interaction of mass as well as energy, mass as well as energy between system and surrounding. Need not to be compulsory, but it should be. It may be possible. Means mass interaction is there between system and surrounding. Energy interaction may also be there. While in the closed system, energy interaction is only there, no mass interaction. Here, the mass interaction is there between system and surrounding. That's why it's called as open system. Energy interaction may be there, may not be there. It depends upon the process adiabatic or non-adiabatic. But there is always a mass interaction. That's why it's called as open system. Means mass can be in and out from between system and surrounding. And there may be energy transfer also. Yes or no? And most of the engineering devices are open system or flow system. For example, air compressor, pump. In air compressor, do you know what is air compressor? In air compressor, the air enters at the low pressure and leaves at the high pressure. And there are also energy transfer across the system boundary. Pump, compressor, heat exchanger. These all are the open system, because in the heat exchanger, if you consider the heat exchanger system, in that heat exchanger what happen? The cold fluid get enter and hot fluid coming out. Or hot fluid enter, it become cool. So fluid get in and out from surrounding to system. Pump. In a pump, if you are going to consider pump a system, in the pump the water get in at low pressure and water coming out at high pressure. And discharge at high pressure. The fluid get in. So in open system, it is a region in a space. It is a small region in a space. The system, in a closed system, the system definition is a certain quantity of matter. As when the certain quantity of matter is fixed by the boundary, which does not allow to pass in surrounding, that's called as closed system. When our fixed region in a space is there and through which the mass can in and out, that's called as open system. Clear? So in open system, here you write open system. This is a closed system. Now here open system. So in open system, it is a fixed region in space through which the mass can in and out. Mass in, mass out. Energy in, energy get out. Mass and energy interaction all are possible. Energy interaction may be there, may not be there. That depends upon the process, adiabatic or non-adiabatic. And most of the engineering applications are the open system or flow system. For example, example of open system is what? Pump, heat exchanger, nozzle, diffuser, compressor, turbine. ठीक है, these all are the open system. In nozzle, here the fluid get in. If it is a region in space, through that space the mass get in and mass get out. Yes or no? So in control volume system, what is fixed here? It's a open system, also control volume. Here volume is fixed. Mass is not fixed, volume is fixed. Means this is called control volume. Here volume is fixed, and through this control volume, it is a control volume is nothing, it is a small region in a space. Control volume is a small region in a space through which mass can in and out. What is control volume? So control volume a small region in a space through which mass can in and out. So what is fixed here? Volume is fixed. While in open closed system, what is fixed? Mass is fixed. Clear? But in a closed system, if mass is not allowed to in and out, then obviously whatever the mass is there, certain quantity of matter, that will be fixed. That amount is fixed. Amount will not be changed in the closed system. Is this clear? Now, isolated system. What is isolated system? The system which have no interaction, having no interaction between system and surrounding, neither energy nor mass. Neither mass nor energy interaction between system and surrounding is called as isolated system. It is of fixed mass and fixed energy. Its mass is fixed, energy is fixed, because whatever mass and energy is contained, it does not allow to transfer. It is a fixed mass and energy. Is this clear? Any problem? Now, thermodynamic properties. What is thermodynamic properties? Every system has certain characteristics. Every system has some certain characteristics is there by which its physical condition may be described. For example, physical condition means what is volume, what is the pressure, what is temperature. So such characteristics are called as properties of system. So every system has certain characteristics by which every system, either closed system or open system or isolated system, every system has a certain characteristics by which its physical conditions may be described. For example, physical condition means what is temperature, what is pressure, what is the volume. These all characteristics of the system is called as properties of the system. And in classical thermodynamics, we are bothering about which characteristics? We are talking about the microscopic properties of the system. Means pressure, temperature. These all properties are microscopic properties, which can be measured by the human operator. Is this clear? Hello? Hello? हाँ सर, गुड मॉर्निंग. अच्छा अच्छा, ठीक है ठीक है. So every system has certain characteristics by which this physical condition may be described. For example, volume, pressure, temperature, and such characteristics are called as properties of system. And these all properties are microscopic in the nature. ठीक है. to define physical condition of system, to define the physical condition of system to define or describe the physical condition of system uh, to describe or define the physical condition system characteristics are required. These characteristics correct of system called as properties. For example, temperature, pressure, volume, etc. ठीक है. तो every system is characterized by every system has its physical characteristics. Every system has some certain characteristics by which its physical condition can be described. And that's called as properties: temperature, pressure, and through these properties we can define the state of a system. Is this clear? Or in other words, you can say, to define the state of a system or condition of a system, some properties are required. This is called thermodynamic properties. So if I'm saying, if all the properties, listen, when all the properties of system have definite value, have fixed value, the system is said to be exist in a definite state, a different condition. For example, this temperature, this pressure, this is the volume, this is enthalpy, this is the entropy, this is the gives energy and all internal energy. All are properties: temperature, pressure, volume, enthalpy, internal energy. These all are the properties. And if a system has, if any system has a fixed value, or you can say when all the properties of a system, all the properties means temperature, pressure, volume, enthalpy, all possible properties of the systems have different value, then the system is said to be exist in a state, in a condition, in a state. Is this clear? If all properties of system has a fixed value, then that system is said to be at a state. A definite state. Definite state. What is state? Condition of a system is called a state. And how can define the condition? by properties. Means this is the temperature, this is the pressure, this is the volume. For example, if I'm saying you, if you want to fix your identity, how can you fix? By knowing your name, by knowing your home district and all, na? So if you saying ki this system is at a state, any system is said to be in a state condition when the properties are fixed. Is this clear? So when the properties of systems are fixed, that system is said to be in a condition of state. Clear? Is said to be said to be at a definite state. Any problem? So first of all, you must know what is properties. Properties is simply it's a in order to describe the condition of a system. In order to the physical condition of system, there must be a characteristics. So some characteristics are required to define the to describe the physical condition of a system, and that is called as properties. So properties are nothing, they are simply used to describe the physical condition of a system, and that's properties may be temperature, pressure, volume, enthalpy, internal energy, and anything else, huh? And if properties, if any system has a specified property or fixed value or certain properties, if all the properties of the system are fixed, have different values of that system is said to be in a state, and this system is said to be have a different state. Clear? So state means, what is state? State means a condition of a system where the properties of the system are fixed. This is temperature, this is pressure, they are not going to change. Clear? When the state will change, state change means properties will change, because state any system is said to be in different state when their properties are fixed. So when the state will change means properties have been changed, and the change in property of a system is called as change of state of system, and change of state is called as process. So why the state of the system, why the property of the system will change? Because of some process has been taken place in the system, है ना? So what is a process? Thermodynamic process. Listen, thermodynamic process. The change of state of a system is called as process, because when the process has been taken place, then only the state of system means property system has been changed. So every state have, at every state their fixed properties are there. So one state has been changed, then properties has been changed. I'm not saying all the properties, but any one of the property will change. For example, if I'm saying this, okay, this is what the state of system is there. Here the volume is V, pressure is P1, temperature is T1. When I just transferring the heat in this process, what happened? Let's say temperature now, all the volume is fixed, but the pressure is now P2, temperature is T2, and volume is V2 is equal to V1. So state has been changed, na? Although any one of the state will change, that will change the state. So initially the system is at different state of P1, B1 and T1. But now when the process of the heat transfer taking place, then the temperature has been increased from T1 to T2. So that is what process is there. So change of state, it means the process is taking place. The change of state of the system is called as process. So what is thermodynamic process? How the normal process is different from thermodynamic process? When the change of state, when the process is taking place through a sequence of states, sequence of So listen. So as the state will change, listen carefully. What is thermodynamic process? It's simple process. The change of state of the system is called as process. What is change of state? Any operation in which one or more of the properties, not I'm not saying key all properties, if at least any one of the properties will change, that's called a change of state. Any operation in which, or any operation that causes change in at least any one property of system is called as change of state. Clear? Any operation, just like here, heat transfer operation causes the change of state. It doesn't change the pressure, it doesn't change the volume, but it changes only temperature. So at least any one of the properties will change during operation, that's called as change of state, and change of state is called as operation or process. What is path? What is path? The succession of state passed through the succession of states passed through during a change of state is called as path. The succession of state passed through during a change of state, because as the state will change, or during a process state will change, so whatever succession of states is there, that's called as path. For example, if any process is, let's say from here to it reached to this here, this is the succession of change of state. The state of the system is changing, this process is changing, and that causes a change of succession of states, that's called as path. Clear? So how can you pass the succession of state passed through the succession of states, ये state है, ये state है, ये state है, there are number of states of 1 2 3 4 5, the states are there. The succession of state, and state is what I told you, at every state the system has fixed value of properties. What is state? Condition of a system is called a state, and to define the state, any system is said to be a state when it have a fixed properties. So succession of state means the properties are changing, and that's called process. So succession of state pass through during a change of state, or during change of state, whatever the path has been followed is called as path. The succession of state passed through during change of state is called as path. Clear? And when the path is completely specified, when path is completely specified, means succession of the state is completely known to you, which path has been followed when the system reached to form initial to final state. Suppose it's initial state to final state, है ना? when system was at initially this way and now finally reached to this, and you know कि system reached from initial to final state through the succession of number of states, that's called as path. So when path is completely specified, the change of state is called as process. The change of state is called as thermodynamic process. Clear? So first of all, what is the process? Change of state. But what is thermodynamic process? When the path is completely specified, that change of state is called as process, thermodynamic process. Clear? For example, I told you when system is at initial state, means at this state its temperature, pressure and volume is fixed. All properties are fixed. That's called state. This is the state of system. Called initial state means at this state all the properties are fixed. This is temperature, this is pressure, this is the volume, this is the enthalpy, this is the internal energy, this is the all and all. Okay? When I just carry out the process and I reach to the final state, this is the final state. We don't know what the path has been followed during the initial to final. So state of system has been changed from initial to final, but we don't know the path. We don't know the path, na? Bolo. It may be like this, it may be like this, it may be like this. Number of possibilities are there. So we are not able to trace the path. That types of process is not called as thermodynamic process. In thermodynamic process, we are more interested in change of state where path is completely specified. Means during there is change of state, when the system is changing its state, the succession of state is well defined. The succession of state pass through during change of state is called as path. So when the path is completely defined, that is called as. It is clear. So here, let's say if you know from initially when I change the state like this, like this is the actual path. Here path is defined. Path is completely specified. That's called as thermodynamic process. They are not thermodynamic process. Thermodynamic process means when the change of state is through infinite number of states. The simple logic is that when the system changes state when the system changes from initial to final state via infinite number of intermediate states, that's called as thermodynamic process. In one line you can write. Then only you can define the path. Yes or no? But you can define the path between initial and final only when the system has changed from its initial to final state via infinite number of intermediate states. Via infinite number of intermediate states. Yes or no? Bro. कोई प्रॉब्लम आ रही है बताओ समझने में कोई प्रॉब्लम how the thermodynamic process is different from the normal process. In normal process when any system is changed state is called as process, but in thermodynamic process we are going to concern about the change of state via infinite number of intermediate state through which the path is specified. Means during the change of state, during the process, our process is to be takes place through infinite number of intermediate states, so that we can define the path where the path is specified. That's called as thermodynamic process. Clear? बोलो भाई छवि. So what are properties? To define the physical condition, to describe the physical condition of a system, some characteristics are required, and that characteristics is called properties. And if all the properties of system has a fixed value, that system is said to be at the condition of state, has a different state. Clear है छवि? कोई प्रॉब्लम बेटा? Now types of properties. It's thermodynamic property I told you. There are two types of properties are there: extensive property, intensive property. Extensive, intensive. Extensive properties are those properties of system which depend upon the mass. Depends on the mass. Independent of mass. So whatever properties, temperature, pressure, volume, enthalpy, entropy, Gibbs energy and all, these all properties we can define in two terms, two way. One is extensive, other is intensive. The properties which depend upon the mass of the system is called as extensive, and which doesn't depend upon the mass is called as intensive. So what is meaning of extensive? Extensive example is volume, enthalpies, total enthalpy. For example, let's say if I'm saying if you have if mass become half, let's say here its mass is m. Here when I divide it into two parts, m by 2, mass become half. Then which, let's say here temperature is there, pressure is there, volume is there, enthalpy is there. ठीक है? Total enthalpy I'm talking about: temperature, pressure, volume, enthalpy, density, let's say, viscosity, let's say. These all the properties are there. Some fluids is there having mass m, temperature T, pressure P, volume V, enthalpy S, density rho, viscosity mu. When its mass become half, is the temperature will become half? Tell me, which property will become half? Temperature I think remains same, pressure remains same, yes or no? Volume become half, enthalpy become half, density become remain same, viscosity remains same. What about thermal conductivity? Thermal conductivity will become half or same? Is thermal conductivity will depend upon the mass of the fluid? So listen, it means volume, enthalpy, they are the extensive properties. So extensive property, the properties which depend upon the mass is called extensive property, and which doesn't depend upon the mass is called intensive. Intensive property example is temperature, pressure, density, viscosity, thermal conductivity, diffusivity. They all are the intensive property, yes or no? Chemical potential, they are intensive. Now extensive properties: volume, enthalpy, entropy, internal energy, Gibbs energy. They all are the extensive property. Because you know, if enthalpy, if the mass of system become twice, enthalpy become twice, because enthalpy depend upon the mass. I'm not talking about specific enthalpy, be careful. I'm talking about total enthalpy. Now, apart from this, all specific extensive is called intensive. Listen, important thing is that all specific extensive properties are intensive. Yes or no? For example, specific volume. Specific volume is what? Extensive or intensive? Volume per unit mass. It means it's nothing volume per unit mass. So when mass become half, volume become half, then its ratio become unchanged. Yes or no? Specific enthalpy. Specific enthalpy. Volume is extensive. Enthalpy is extensive. So that's why specific extensive is intensive. Kilojoule per kg or H by M. Intensive. Specific entropy. S by M. It's called a small h. This is called a small v. It's called a small s. Specific internal energy is called capital U by M. Is called a small u. Similarly, specific Gibbs energy, that's called capital G by M, is called small g. Specific Helmholtz energy and all specific extensive is called intensive. Clear? कोई प्रॉब्लम? Now come to the next thermodynamic state. Already I told you what is state. Any system is said to be in a state when it is a fixed value of properties. Yes or no? When it is a different value of properties or fixed value of properties, where properties are fixed, that system is said to be in a state. So how can you fix the value? If any system is there, let's say, and I told you कि state means condition of a system is called state, and any system is said to be in a state or definite state. Any system is said to be in a definite state when the properties of the system are fixed. Yes or no? All the properties of system are fixed. So what is the condition for any properties? In which condition the properties of the system are fixed? That's what my question is that. So listen, any system is said to be in thermodynamic state if following conditions are satisfied. First, first, all intensive property must be uniform. Second, and it should be invariant. invariant with respect to time. Clear? Uniform and invariant. When the intensive properties of systems are uniform and invariant. Why I'm talking about intensive, why not extensive? Because I told you extensive property is the gross properties. Volume is not the property of any point, because temperature we can measure at different point, but we can't measure volume at different point. Volume is a gross properties. Mass is a gross property, है ना? That's why. So any system is said to be in thermodynamic state. Any system is said to be in a thermodynamic state if following conditions are going to be satisfied. Which conditions are there? Ki at this condition, if all the intensive properties of the systems must be uniform. Uniform means throughout the same temperature, same pressure, throughout each and every point. Temperature is same, pressure is same. Clear? तभी तो फिक्स वैल्यू होगी ना, because if you see the normal definition of a state is what? When the properties of system are fixed, when all the properties of system are fixed, that system is called a state. यही है ना? तो फिक्स कब होगा? Fixed means what? Means the properties must be uniform throughout the system. It should be same temperature and same pressure. It should not be at this point different temperature, at this point different temperature. It should not be there. Because if it is there, then what happened? Then properties are not fixed. The temperature is changing at different points. The properties must be uniform and it should be invariant with time. The invariant means it should not be vary with time. For example, let's say at this moment we have found the temperature is 100. Now at other moment we can define the 110 degrees Celsius. So can we define the system as a state? Can you define the system as state? Because how can you define the property? Because I told you when it has fixed value कब होगा? When temperature is 100, pressure is 100 kilopascal, volume is this. If their temperature, if their values are changing continuously with the time, then we can't define the system as a state. We can't say this system is a state. Yes or no? So I told you state is nothing, it is a condition of a system when all properties of the system, or especially intensive property of system, are a fixed value. The properties, intensive properties must be uniform and it should be invariant with respect to time. Then now, so if let's say if any system is there, it has this temperature, this pressure, this is the specific volume, this is enthalpy, specific enthalpy, or intensive property, specific volume, density and all. So this, if the temperature is same throughout, pressure is uniform, enthalpy is uniform, all are uniform and they are invariant with time, means their fixed value are there, then this system has a different state. Yes or no? This system is said to be in state condition. My dear student, that system, that properties of the systems are not going to change. It means system is in dead state, system is in equilibrium. Yes or no? By in which condition the properties of system is not changed? When the system is not going to interact with surrounding. When system is not going to interact with surrounding, then only the properties of system will not change. Now when system is going to interact with surrounding, then their properties will change, and the changing properties called process. When the process is taking place in system, any process, heat transfer, mass transfer, or any imbalance of forces, if any process were taking place in the system, then that causes the change of properties, and change of property of system is called as process. I told you in the previous. Change of properties, a change of state of system is called as, when the state of system is changed from T1 to T2, it means process is taking place. So now, so by this definition, there is one confusion is there. Can I say only isolated system as a state? Because in isolation system, system is not going to interact with surrounding, then only the properties will not be changed. Yes or no? Because when the system is not going to interact with surrounding in any way, then only the properties were fixed. They will not be changed with time, they will not change with the space. Uniform is what? With respect to space. The properties are going to be uniform and in a time only when the system is in isolate with surrounding. Yes or no? And that's called as all our system is in equilibrium with surrounding. When system any process is in equilibrium, it means that no change is going to take place. No change is taking place. So either means according to this definition, any system is said to be in a state only when either system is isolated or system is in thermodynamic equilibrium with surrounding. Then only there will be no change in the properties with time and with space. Then only we can say this system is in a state. That seems to be yes or no? But in thermodynamics, we are mainly we are in thermodynamics we are talking about the change process. So for the process to be takes place, properties of the system will change, then state will change. That's why this definition has to be modified. So what modification is there? The all intensive properties must be uniform and it should be invariant with time, at least for the time at which we are going to define system as a state. But all time it's not possible. If all time the properties are going to be constant, it means no process is taking place. And we are basically thermodynamics, we are dealing with the change of state, because energy and energy interaction, and when energy and energy interaction will taking place with surrounding, then change of state will be there. Clear? That's why we are going to modify the definition कि the any system is said to be in a state when the properties or intensive properties are uniform and it should be invariant with time, at least for the time, not for all time, at least for the time at which we are going to describing the system as state. Is this clear? For example, if I'm saying कि at this moment this is temperature, this is pressure, at other moment other temperature, other pressure is possible, at next moment other temperature. For example, when the system is changing the state from initial 1 2 3 4, they are the succession of process, this path. So at least when we define the system at state 1, then we have fixed temperature, fixed pressure, fixed volume. When system reaches to second state, then at second state we are able to know the temperature, pressure and volume. We know the temperature, pressure and volume at third and fourth. So at least for the moment where we are going to describe the system as a state, we should know at least for that moment the properties must be not changed with the time. Is this clear? So can you say every state is in, okay, is this clear, yes or no? So state means, a simple definition is that state means a condition of a system where the properties are fixed, at least for the time at which we are going to define the system as a state. Because all times it can never be possible key properties are fixed. If all time properties are fixed, means the process is either isolated or the system is in thermodynamic equilibrium, means no process is taking place at all. But we are not going to discuss this type of process, this type of system. We are going to interested in the system which are going to interact with surrounding, and when the system is going to interact with surrounding, there is always properties will change, and change in property means state will change, है ना? So that's why the state means at any moment of the time, at certain moment of time when we are going to describing the system as state, at that condition the properties are fixed, well defined temperature, well defined pressure, well defined volume and all. Is this clear? ठीक है. Okay, now write down equilibrium. What do you know by equilibrium? The absence of change. Yes or no? In a state of equilibrium, is the system is in position to interact with surrounding in any way, in heat transfer, in work transfer, in energy transfer? Tell me please. When the system is in equilibrium with surrounding, is the system is in position to transfer the energy transfer to interact with surrounding? So what is the equilibrium is there? Equilibrium is a concept. It is general definition of equilibrium. Equilibrium is a concept associated with absence of any tendency, with the absence of any tendency for further change at a macroscopic level. Clear? So this is our definition. It is a concept which are associated with the absence of any tendency for further change at the microscopic level. Clear? Means there is always absence is there for any tendency. There is no any tendency for change. At which level? At the microscopic level. Means as a human operator, we are not able to change any. We are not able to find any change. Although at the microscopic level there may be change, but at the microscopic, at gross behavior will not be changed. Gross properties. So what is the properties at the microscopic level? Temperature, pressure, volume. They will not be changed when the system is in equilibrium. And if you see, if there is no change in the properties of system, it means at the equilibrium I told you ki system is in the absence of process, or you can say it is a concept that is associated with the absence of any tendency for further change. So there is no any change is there in the properties of system. If there is no change in properties, means properties are uniform and invariant with all time, and that's called a state. So can you say in reverse every state is in thermodynamic equilibrium? Yes or no? Every state is in thermodynamic equilibrium, because state definition is also same. In a state, any system is said to be a state when the properties are uniform and invariant. So at least for the moment where we are going to define the system as state, at that moment that system is in equilibrium with surrounding. Yes or no? every state is in thermodynamic equilibrium. Okay, before this we must know what is the thermodynamic equilibrium. Thermodynamic equilibrium. When a system is in mechanical, chemical and thermally equilibrium, then system is called as thermodynamic equilibrium. Please write down. So for system to be in thermodynamic equilibrium, system must be chemically, mechanically and thermally equilibrium. When any one of them will present, then it is not in thermodynamic equilibrium. It may be thermal equilibrium. Thermal equilibrium means equality of temperature. What is the meaning of thermal equilibrium? Thermal equilibrium means system. What is the meaning of thermal equilibrium? Anyone? When there is no variation in temperature within system or in system and surrounding. When there is no variation in temperature, when no variation is found in temperature within the system and also within the system and surrounding. So if there is no variation in the system, no variation in temperature within the system, no heat transfer, and if there is no variation in the temperature of system and surrounding, then there is no heat transfer between the system and surrounding. That system is said to be in thermal equilibrium. Yes or no? So this implies equality of temperature. Equality of temperature. Now what meaning of mechanical equilibrium? Mechanical equilibrium means if there is no any imbalance of forces either within system or between system and surrounding. If there is no any imbalance of forces means, for example, let's say this is what piston is there and here the gas is there and here I place some weight. So pressure exerted by the weight is P1 and pressure exerted by the gas is what P2. Then if P2 is more than P1, then is the force is balanced? Tell me. The pressure exerted by the gas from inner wall of the inner gas and the P1 is the pressure exerted by the weight of the piston. Is the force is balanced here? So there is imbalance of forces is there. So that system is not to be in the mechanical equilibrium. Yes or no? So for mechanical equilibrium there should be a equality of pressure or equality of forces. Yes or no? That's what equality of pressure or forces means if there is any imbalance in the forces, if there is no imbalance of forces in a system within it is isolated, it is said to be in mechanical equilibrium. Now chemical equilibrium. If there is no change in concentration or chemical compositions, no chemical reaction, if chemical reaction taking place, then what happen? The composition will change. Huh? So that's equality of chemical potential. No mass transfer is there. Equality of chemical potential means when system is in thermally, mechanically, chemically equilibrium, means system is not able to transfer the heat because of temperature is same. System is not able to displace any position because of force is balance. Here piston can be moved here because P2 is more than P1. But if P2 is equal to P1, piston will be at the rest. So it means if the system is in thermal equilibrium, it is not able to transfer the heat. If system is in mechanical equilibrium, system is not able to displace any position. Now if system is chemical equilibrium, there is no change in composition, means there is no mass transfer is there, no mass transfer, no heat transfer, no any imbalance of forces, then that system is in dead state, means that in that system there is no change is there, there is absence of any changes there. So absence of any tendency for the further change is called as equilibrium. So that system is said to be in thermodynamic equilibrium. Yes or no? So for system to be in thermodynamic equilibrium, it must be mechanically, chemically, and thermally equilibrium. It means system is in positions to do nothing. It is in dead state, and dead person cannot be in touch with anyway with surrounding. Yes or no? Clear? Hai? And let's say if you have a system, and if system is in thermodynamic equilibrium surrounding, sorry, if system is thermally equilibrium surrounding, means temperature is same, no heat transfer is there between system surrounding because temperature is uniform. If system is in chemical equilibrium, means there is no any chemical reaction is taking place within system that causes no any change in composition. है ना? If system is in because when the composition will change, then what happen? Because if chemical reaction is taking place in a gas, then what happen? Moles may be increase or decrease, and that causes the pressure to be increase and decrease. Yes or no? So if pressure will change, then change will be there. What I'm saying to you, equilibrium means no change is there at any level. So that's why if system is in thermally equilibrium surrounding, means temperature of system surrounding is same, no heat transfer. If system is in chemical equilibrium, chemical potential is same, no mass transfer is there, no chemical reaction is there. And if system is in mechanical equilibrium, no imbalance of forces is there, then it means all the properties of the systems are fixed, they will not change with the time. Yes or no? And they will be uniform. That's why no heat transfer, no mass transfer. Yes or no? So they are uniform and invariant with the time, and that is definition of state. Means we can say when the system is in thermodynamic equilibrium, it's called a state. It is a condition of a state. So every state is in thermodynamic equilibrium. Can you say? You can now every state is in thermodynamic equilibrium, not thermal. Thermodynamic equilibrium means absence of any change. You will not found any change in their microscopic properties like temperature, pressure, and all. Clear? कोई प्रॉब्लम? The properties of system can only be fixed when system is thermodynamic equilibrium. है ना? Yes or no? बोलो भाई, कोई प्रॉब्लम यहाँ तक अभी? हाँ now now I describe the equilibrium, thermodynamic equilibrium. Okay, please revise things. You can ask if you have any doubt. टॉपिक ही भूल जाता, पाना क्या है यार। तो ऑल बेसिक about thermodynamics I told you, these are important to, these all terminologies are frequently come when we, हाँ, now याद आ गया। State post heading is state postulate, state postulates। Write down. Anyone have idea about this state postulate? Anyone have idea about this state postulate? Yes or no? What is state postulate? No idea? Yes or no? Now listen. That's very good. State postulate means in order to define the state of a system, I told you the properties must be at every state the properties of systems are fixed. Yes or no? By state postulate means state. What is state? I told you it is a condition of a system at which the properties are fixed. The question is that to define the state of a system, is it required to fix the all? Is it required to fix the all, or is it possible? Suppose I want to define this as state here. So how many variable has to be fixed to define the state? How many minimum number of variable has to be fixed to define the state is called state postulate. It define number of independent intensive minimum number of independent intensive variable has to be fixed to define a state. Means how many number of variables, how many number of independent intensive variable or properties, you can say properties, has to be fixed to define the state. Because I know at each states all the properties are fixed, but how many properties has to be so high, how many minimum number of properties has to be fixed to define the state? It's called state postulate. Yes or no? Bro, how many of you got this point? तो भाई मैंने क्या बोला, at every state, at state all the properties are fixed. So to define the state, if you want to define a state, how many minimum number of variable has to be fixed? By there are infinite number of, there are very large number of variables are there. So is it required to show all, it is required to fix all variables, or only few variables are sufficient to define the state? Is called a state postulate. कोई प्रॉब्लम? So according to state postulate, the number of independent intensive variable need to specify all the intensive variables. Listen, since f equal to c plus 2 minus p, let's say if I have a pure component, so how many pure component, how many components, a single component system is there, then one. How many phase is there? Let's say one. So 2 is there, f equal to 2. It means to define the system, how many number of variable has to fix 2, and that's what is the state postulate, is that from this the state of simple compressible system, simple compressible system is completely specified or defined by two independent independent intensive vari properties. Intensive properties, clear? Means only two is sufficient, and that's why to define the state we should only know y and x. These two properties are there to define the state. Let's say if I'm going to y and x, then the state is one is defined. Once I know this y and this x, then all other properties we can define. So need not to know, there is no need of defining all the properties to fix the state. Is this clear? If you have a simple compressible system for pure component or single component system is there, simple means one component and one phase, then degree of freedom is 2. It means the only two properties has to be, and which two property? Independent intensive, which has to be fixed to define the state of a system, and by fixing the two, all other properties at that state we can define. Is this clear? So what is definition of simple compressible? I will discuss. For example, if you have piston cylinder assembly is there, and here nitrogen gas is filled, nitrogen, temperature is 25 degrees Celsius, and pressure is given, let's say 1 atm. So only the two properties are fixed, then I can find the other properties, because I told you every at state all the properties are, means at the state the properties are defined. There is fixed properties are there, all the properties are fixed, means temperature and pressure. So at the given state there are number of properties are there: temperature, pressure, specific volume, specific enthalpy, specific entropy, specific energy and all, huh? So by knowing the only two, we can find the rest properties by the help of these two. Is this clear? That is called a state postulate. That's why only two coordinate system is sufficient to define a state. If you want to define the state 1, then we must know y and this x, and y and x is the independent intensive property of a system. Any two, if you fix, then all other properties we can fix. No need to define all other properties. By knowing the two, we can find the rest all. Clear? Similarly, at the rest 2 point, at the other 2 point, if we know this y and this x, then I can find the all other properties at the second state. Similarly, at any other intermediate states, we can find the properties by knowing the only two properties. Is this clear? So to define the state of a system, the only for simple, if you have a simple compressible system, then only two independent intensive variable properties has to be fixed to define the system completely. Clear? Now the question is, what is called a simple compressible system? A simple compressible system is in the absence of any electrical, magnetical, gravitational motion and surface tension effect. Means we are not going to bother any gravitational force, because when the gravitational force will be come into picture, then the pressure will also going to vary along with the hydrostatic head. Yes or no? P from in the fluid mechanics we know dP upon dz equal to rho g, weight density of the fluid, pressure variation with depth. Then one more variable has to be fixed. 3 variables will be required. Yes or no? Let's say the pressure is going to vary with depth here, then one more variable has to be fixed. So I am talking about simple compressible system. Means the system, a system, note here, what is called a simple compressible system? A system is called a simple compressible system in the absence of electrical, magnetic, gravitational motion and surface tension effect. These effects are neglected. That system is called a simple compressible system. A system is called simple compressible system in the absence of electrical, magnetic, gravitational motion and surface tension effect. ठीक है? कोई प्रॉब्लम बेटा? So these properties must be independent. Now at the same time, one more example, a special case. If C is 1 but phase is 2, then how many variable has to fix to define the state? One is there only. Means, for example, if you have a liquid water and water vapor, water and water vapor is there. It's a vapor of water. It's liquid vapor. So only one component but two phases there. And if they are in equilibrium, then only one property is sufficient to define the state. Yes or no? Tell me. In a two phase, special case, if two phases there, then only one variable is sufficient to define the state of rest. All properties we can define by knowing the only one variable. So to define the state in two phase mixture of pure component or single component, only one variable has to fix, either temperature or pressure or any one. For example, I would like to give you example. Let's say I told you, if you have water is there, liquid water, and this is water vapor. So one component but two phases there. If they are in equilibrium, if this liquid and vapor are in equilibrium, then to define the state of equilibrium, only it is state of system and state is in equilibrium. To define the equilibrium, only one variable is sufficient. For example, if at the pressure of 1 atmosphere, tell me, at the pressure of 1 atmosphere, if the liquid and liquid vapor are in equilibrium, then what the temperature will be? 100 degrees Celsius? Yes or no? Bolo. At the pressure of 180 means only I fix the pressure. I know the temperature. I can also find out the specific volume of the vapor and liquid. All the properties we can define from a steam table. By only knowing the pressure of 1 atm, so you can search from the steam table ki at 1 atm at which temperature the liquid and liquid vapor will be in equilibrium at the temperature of 100 degrees Celsius. Clear beta? Vice versa. If they are temperature of 100 degrees Celsius, then what the pressure will be 1 atm. We can find the rest properties, entropy, enthalpy and all by knowing only one variable. Is this clear? This is called a state postulate. And that's why in simple compressible system, two variables are required, two independent intensive, and that's why this y and x, please draw this figure, y and x are the variable properties, and these two properties, when two properties are going to fix, then I can define the state. Only two is sufficient, although we can show the all, but unnecessarily we are going to increase the complexity. If only two is sufficient, then what is the need of defining all others? Huh? Clear? This is what the state postulate. Now, this is quasi-static process. Quasi-static process, also called as quasi-equilibrium process. Quasi-equilibrium process. Anyone have idea about this quasi-static? Quasi means almost, and static means stop. Almost stop process called quasi, means very slow process is called as quasi static process. Very slow process is called as quasi static process. Clear? And what is process? Change of state. When it means when the change of state is taking place very slowly, That's called as quasi-static. Clear? For example, if let's say if this is the piston cylinder assembly is there, through example I am going to discuss here. This is what the piston, and that's what cylinder is there, and here gas is filled. So when the process proceeds in such a manner that system remains infinitesimally close to an equilibrium state at all time, it is called as quasi-static. And this process is sufficiently slow process. And this process is so slow that allows the system to adjust itself internally to, so that the properties in one part of system do not change faster than those at the other part. So listen, how can you assume the quasi static process? Listen carefully. कोई प्रॉब्लम यहाँ तक बेटा? So listen, here let us consider a system of a gas contained in a cylinder. System is initially in equilibrium with is in equilibrium state. System is because system is in equilibrium means it is in equilibrium surrounding. Surrounding means obviously the temperature, pressure, all the properties of the system is uniform and invariant with time. That's why system is called state. And here a small slice, small plates were placed over this, and this is weight is W, and means weight is placed over the piston. Just try to understand here. And here there is stopper is there. It is stopper. When I remove all weight at once, what happen? Initially system is in equilibrium. It means there is no imbalance of pressure, force, no imbalance of temperature, no imbalance of chemical potential. Pressure force means force is balanced, means system is in mechanical equilibrium. So actually system is in initially system is in thermodynamic equilibrium, and every state is in thermodynamic equilibrium. And thermodynamic equilibrium means here there is no imbalance of pressure, force means whatever the force exerted by, here the force weight force exerted by the weight W of the over the piston is balanced by the force exerted by the gaseous molecules on the interior of the wall. Its force is balanced. Bolo? Means at equilibrium what happen? At mechanical equilibrium, I am talking about first. At mechanical equilibrium force is balanced. It means W is the weight weight upon area of the piston, that will give the pressure force, and this is equal to pressure exerted by the gas from interior. The pressure external equal to internal. So it's called external pressure, and that is also equal to internal pressure. Internal pressure means for pressure exerted by the gases molecules, and if they are equal means force is balanced. Yes or no? Bolo. No imbalance of forces. Now at the same time, temperature of surrounding is same as temperature of system. This is what system is there. I'm going to show you what is system. Boundary will define what the system is. This is what the boundary, and anything beyond the system is called a surrounding. This is my system. Temperature of surrounding is same as temperature within the system. So it also indicates you thermal equilibrium. This indicates you mechanical. This indicates you thermal equilibrium. And since no chemical reaction is there, then no need to bother about chemical equilibrium. So system is already in thermodynamic equilibrium because system is already in the mechanically and thermally and chemical equilibrium. Okay. And this is what initial state. And initial state is temperature T1, pressure P1, volume is V1. This initial state. Although only two variables is sufficient to define the state, I told you, let's say temperature T1 and pressure is P1. I told you from state postulate, two variables is sufficient to define the state. Once I know temperature T1 and P1, I can find the volume, I can find the enthalpy and all rest property we can find. So no need to write all properties. That's why we have defined the state postulate. Its initial state, T1 and P1. Clear? So weight on the piston just balance the upward force exerted by the gas. And if the weight is removed, what happens? When we remove the weight at once, there will be an unbalanced force between the system and surrounding. And under the gas pressure, piston will move up till it's hit the stop. Yes or no? Tell me please. When we remove all the weights at once, what happens? This causes, when we remove the weight, then is causes imbalance of forces. Pressure of the gas inside is more than the pressure outside now become, because we have removed the weight, and then piston will move up and it will slams on the top. This piston will move at this point. This stopper was there. Although piston will try to go much more above, but it will not able to do because of stopper. Yes or no? So this is what initial and this is what final position of the piston. This was initial position of the piston were there. Now final position of the piston were there. Now this one at the stopper. When we remove the weight over it, and this process is quite fast. Yes or no? This process is quite fast. Now my question is that are you able to define any intermediate property? Let's say at state 1 you are able to know what temperature, what the pressure is there, T1 and P1. Now at final, when it slams on the stopper, when it reaches to the topmost position at the stopper, then piston will get slams and strike on the stopper, and after some time it will get reach to the equilibrium, and again it will attain the new equilibrium condition. Yes or no? New equilibrium condition will established. Now my question is that are you able to define any intermediate properties of the system? Are you able to define, initial and final state? Can you define any intermediate states? State means what? Where the properties can be defined. Can you find any intermediate states between initial and final? Can you measure the pressure, temperature, or any other properties? Let's say only two properties sufficient. Can you define the state of the system at any intermediate point between the initial and final? No. Why? Because it's very fast. It's a very fast process. You are not able to, no device can measure. If you are placing the device, that device will fluctuate with time, and that will not give you the reading. If you place any devices like pressure gauge and thermometer, that will not able to measure, will fix, that will not give you any fixed value. And when you are not getting any fixed value, it means the system is not defined. There is no state is there. For a state, any system to state property must be fixed. You are not able to, you are not in position to define the state. You are not able to measure the process variables. We are not able to define the property of system at any intermediate points. Yes or no? And that's called as non-quasi process. Means fast process. Yes or no? So let's say if I'm defining here pressure and here specific volume is there. Two intensive property I have taken here. Two properties are sufficient to define the state. And this is what expansion is there. Gas is going to expand from one is the one here, and this is the two here. Listen carefully. In this case, the work is expansion is against which pressure? External pressure, atmospheric pressure, yes or no? Because when we remove the weight, then only pressure against which the piston is going to move is called as atmospheric pressure or external pressure. Yes or no? So here at initial condition the pressure was P1 and volume was V1. That is known to you. It's pressure P1 and volume is V1. Clear? When you reach from 1 to 2 state, when the volume has been increased from V1 to V2, so which pressure is known to you? Only P2 is known to you, and it means the pressure against which the piston has been expanded. The only resistance force against which the piston has been expanded, gas has been expanded, it's the atmospheric pressure or external pressure, and this is what P2 is there. Then how much work is done by the system? It's P2 into V2 minus V1. Work done is, because work is nothing, force into displacement, and force against which the displacement is there, that is called as external force. Yes or no? The force, it's P external into area into displacement, and area P external pressure, area into displacement is called volume, change in volume. Area into displacement is nothing, it's change in volume, P into delta V. This work is there, yes or no? So only this much work is there, P into V2 minus V1. P only pressure that is known to you, what? P2. No other pressure we know when the system reaches to the initial to final state. Yes or no? Tell me please. And this is called as highly irreversible process, because process is very fast, and the gas here, the piston moves against the external pressure, and which means gas does work on the surrounding to remove the surrounding, na? Because when the gas will expand, it will simply remove the gas, surrounding gas. So when the piston will move, the system does work on surrounding. Yes or no? System does work on surrounding. So how much work is done? To find the work is force into displacement. Force is pressure into area. Now question is which pressure we should write? Because you don't know any intermediate pressure. You only know the external pressure. Only you know the external pressure. Yes or no? You don't know any other pressure. Now same process if you are going to repeat in this way. If you are going to remove half portion, If I remove only half of it, let's say the same here, gas is there, piston is there, now same weights were slides were there, only half of this we removed. Now a rest half we remove. When we remove first half, listen, try to understand here. Again the same position is 0 here. Now in this case, here I have a some space is there. I just remove this much portion of the weight, half portion. Let's say total mass is m here, I just remove m by 2 here. When I remove m by 2, better is that you should know here. Here I just remove at this position, initial position, I remove m by 2 here. Then the piston will move some distance. Let's say this is what one intermediate point I got here, and here only I have half of the weight. Now again when I remove rest half m by 2, then I get the again the final position, this one, yes or no? So how it is different from the first case? In the first case all weight, all m mass we have immediately removed, but in the second case what we are removing is half of it in once and second half in the rest part. The initial and final point is same, but here I got one intermediate point, yes or no? At this intermediate point, this is intermediate point is there. At this intermediate point, can we define the state, yes or no? Tell me please. So here in this let's say here P1, let's say I got here PI. PI is the intermediate pressure, intermediate volume, intermediate temperature is there. Some internal value I got here. So in this case, how much work is there? PV diagram. So in this case again, initial condition is this one. It's one condition I told you. Initial condition. Volume is V1. In this case, I got one intermediate pressure. This is what the P. Obviously, intermediate pressure is lower than the previous one. It's P intermediate, and this is what P2. Here P1 is there. At the PI, I got volume is VI, and here I got the volume V2. Finally, V1 and V2 is there. Volume has to be increased from V1 to V2, but now in this case I got intermediate value of pressure. So in this case, how much work is there? In the first stage, how much work is there, anyone? In the first stage, against the pressure P, the volume has been changed from the V1 to VI. So from V1 to VI, the pressure has been changed from P1 to PI. So this much work is there. In second part, yes, very good. In second part, VI to V against this pressure. This is what is there. Yes or no? This much volume is there in the second part of the work. So this work, and obviously in the second case, in the first case only I got this much work. Only I got this much work, yes or no? In the first case, when I have only one, no intermediate pressure were there. But now in this case, I got this much pressure is there. This much pressure, this is work in the first part, and this is work in the second part, and that work is more than the previous, yes or no? So work done by the system is going to be increased when I got the one intermediate point, yes or no? Tell me. Because in the first case, only the P2 was pressure that is known to you against which the gas was expanding. But here, the gas is going to expanding with against some intermediate pressure. Against some intermediate pressure, that is what Pi. So from in Pi, the volume has been changed from Vi to V1, and then in second, the pressure is what P2, and in that the volume has been changed from Vi to V2, and that is vastly more than this. Similarly, when I repeat the number of infinite number of intermediate steps, when I remove slide one by one, when I remove the slides over the weights that I put in in form of slides one by one, let's say first slide, then I got small differential increase, then other slide, then a small differential increase, and if I got through initial to 1 to 2 condition via infinite number of intermediate states, via infinite number of intermediate each states, at each stage, because one by one we are going to remove the slides, we are not going to remove all the weight at once, we are going to remove the weight one by one, very small weight we remove, then I allow sufficient time to reach the equilibrium. So in this case, when I remove when I do the process in quasi-static manner, means almost slow process, then the system is in position to reach the thermodynamic state at each state, means process is going to take place by infinite number of intermediate states, and each state in thermodynamic equilibrium. Yes or no? Then the same can I write in this way? Let's say PV diagram is there. Listen, this is one here, and you can see its P2 is there, just like P1 and P2 as it is. But now in this case, I have one in number of in pressure, in that pressure range, this much volume change is there. In second pressure range, this much volume change is there. In third pressure intermediate state, this much change in the volume. Similarly in this, like this. Can you imagine? So this is if the change in volume is very small, if this is the differential change in volume and differential volume is very small, dV close to 0, means very small weight we are going to remove, very slow process. When we are going to remove a very small weight object, let's say for example, if you are going to, all the weight is going to be ground by the powder, and we are going to remove particles slowly, you know what happened? I got this types of core, yes or no? This is what here it's P, and this is what dV is there, and this is differential work is P dV, and if you integrate over entire, this will give you the total work done. Yes or no? Follow. So when it means when I am carrying out the process in quasi-static manner, so what the advantage we are getting? We are getting more amount of work. Yes or no? But for the quasi, if you took quasi-static process is almost a process, and in this process we have to, and this is called as actually thermodynamic process. All thermodynamic processes are quasi-static, because I told you thermodynamic process is the process which are taking place via infinite number of states between initial and final. And this process is so slow that it is passing through infinite number of states between initial and final, and each state is in thermodynamic equilibrium, means system is in positions to attain the thermodynamic equilibrium condition at each state. Is this clear? Bolo. If you compare, this is what the work we got when quasi-static manner. When I do the same process in now in a first case, when I remove all weight at once, then only I got this much work. Only I got this much work, yes or no? Now the question is, what is the importance of this almost slow process? In real practice, in real conditions, is there any process which is such slow? Tell me please. So all thermodynamic processes are quasi-static, almost slow, very very slow process. Now the question is that why we are going to bother almost slow process, a very slow process in thermodynamics? That's the question, because in real scenario, no process, you might have seen the many expansion and compression of the gases, they are very fast. Yes or no? So why we are going to bother about this slow process? Because it produces maximum work when in expansion, maximum possible work, not maximum possible we should say, means because this produce more work, yeah, and this can act as a reference to compare all actual expansion processes. In this case expansion is there, same thing in compression. When you compress the gas, you should try yourself. When you compress the gas very fast, then you found the work is maximum. But when you compress the gas in quasi manner, you will found the minimum work should be required, means less amount of work is sufficient is required to compress the gas. More amount of work when you more amount of work you can obtain when you carry out the process slowly, and less amount of work is required to compress the gas when you going to carry the process quasi manner. Is this clear? More and less. So all actual processes you can compare, because there should be some reference now, so that we can compare how much of our process is, because I told you more fast process less amount of work will be produced if you're going to expand the gas. So there must be something so that you can compare how much is our efficiency. So for all actual processes, this quasi process act as a reference, so that you can compare your actual process with the ideal process. Is this clear? Because I told you thermodynamics says the limit. No, you can't produce more than this. So whatever your device is producing, you should compare with the ideal, what the maximum possible is there and what you are producing. Because if you don't know what maximum can be produced, then you will be happy I am producing maximum. Yes or no? If you don't know what the maximum is there, then everyone is happy with their values, yes I am producing maximum. No, that's why I told you thermodynamics limits the set the boundary. This is what the maximum possible, and what your device is going to produce. The maximum and minimum also. The minimum in the case of compression, when you compress the gas, then work is required. The minimum work is required when the process is quasi-static. Clear? When you expand the gas, work is produced. Maximum work is going to produce. A more amount of work is produced in a given change of state when the process is quasi-static. Clear? बोलो बेटा. तो what is quasi-static? Is this clear? When you compress the gas, same thing here. When you are going to put the weight, initially this is the condition. When you put all the weight at once, here weight were there. When you put all weight at once over it, what happen? This will lead to the final. It's initial one condition, it's final condition. When you put all the weight at once, the volume is V1 to V2. When you compress the gas, then there is no any intermediate state is there, na? There is no any intermediate state is there. It's P, it's V here. So initial state is this one. Initial state, when you compress the gas, then this is initial state. Volume was high, it's V1, pressure was P1. Initial state. When you put weight over it, then it is compressed against the pressure of what? P1. Sorry, only the pressure is not to be P2, na? Final pressure, yes. So, and final pressure is obviously more. So it's what is the second state. One state, second state, it's P2 here. And total work done is what? Pressure into displacement. The pressure is only known because no intermediate pressure is known to you. Only the pressure is what? P2. Then P2 into P into V2 minus V1. This much work is there. Throughout only the pressure known to you is what? P. So this much work is there, yes or no? Bolo? For compression. When you are going to compress the gas in two steps, here only half portion you are going to put here, then you will get one intermediate state here, then in second you can put the rest other, then it's 1 and 2 here final. In this case you will get one intermediate called PI. In this case you can see pressure into volume, V1 to V2 here. Here initial condition is this P1, here volume is V1, yes or no? When you compress the gas finally, it's what? P2 and here V2. But again you got one intermediate pressure is what? PI. When the PI is there, then from here volume has been changed from V1 to VI. It's what? VI is here. So listen, PI, VI to V1. This much work is there first, in the first state. In second, pressure is what? P2, and against the P2 the volume is changes this one. This much volume is there. So only this much amount of work you have saved as compared to the first. When you repeat in 3 steps, what happen? When you increase the number of steps, pressure versus volume, it's 1, it's 2. Let's say one intermediate is your P here, another is there, let's say it's P3, it's P4, like this. 2 intermediate pressure points we have shown you here. In this case, so here the 2 volume will be there. In the first I got this much. In second I got this much. In third I got this much. Now again you can see I have saved this much amount of work. Saved. Less amount of work is required. When I carry out in infinite number of steps, then I got these steps of P into V from V1 to V2 through infinite number of states. This much area. बोलो clear है कि नहीं? When I have infinite number of steps, so I just save this much whole amount of work we have saved. So you can see when we are going to carry the process in quasi manner, then in terms of compression, in compression the minimum work is required, and in expansion maximum work is produced. Both is beneficial for us, yes or no? And that's why in the case of work producing, so when the process is quasi-static, then for work producing system in expansion we got the maximum work, and we got the minimum work when compression is there. Minimum work is required, maximum work is produced, and both set the standards for the reference standard for the all actual process of compression and expansion. Is this clear? बोलो क्लियर है नहीं? तो कुछ क्लियर हुआ थर्मोडायनेमिक्स? थैंक यू सो मच। कुछ भी याद करने वाली चीज़ नहीं है, देयर इज नथिंग विच यू हैव टू रिमेंबर। थैंक यू सो मच।